Hi everyone, in this video we would be designing the parking lot system. And this question is very popular in Amazon low level design round. So that's the reason why I am covering this question in this low level design series. So let's get started. So this is the flow that we would be following in each and every video in our low level design series. The first step is understand the system. And I believe this is one of the important step because let's assume that I ask you to design snakes and ladder and I also ask you to design Sudoku. Then the chances are high that you'd be able to design snakes and ladder because you have definitely played the snakes and ladder in your life. And the chances of you having played the Sudoku is comparatively less. So you might not know about Sudoku. Right. So if you don't know anything about Sudoku, then obviously you can't go to the next step. So that's the reason why we would always try to first understand the particular system briefly. Once we understood that system, we would go to the requirement gatherings part. And what I've done is, in order to simplify this requirement gathering steps, I have categorized that requirement gathering into three categories: extensibility, dynamic, and high traffic. So all the requirements related to extensibility will go into this category. So assume that currently your system has Stripe payment gateway and PayPal payment gateway. But in future, you might want to add some other payment gateways as well. So that requirement comes under extensibility because you might want to add something in the future. But while adding that, you don't want to modify the old code. So that requirement will come into extensibility. Similarly, let's say currently you are charging your customer based on time, but in future you might want to charge your customer based on event as well. So this requirement will also go under extensibility category. The second category is dynamic. So all the requirements where user will provide the input will go into this category. For example, let's say we are playing tic-tac-toe. So over there, we can ask the size of the board from the user. We can also ask the number of players from the user. So all those requirements will go under dynamic category. The third is high traffic, or you can say concurrency. So assume that you have a website which allows the user to book a ticket. Now there is one movie going on and it has only one ticket available, I mean one seat available, and two users are simultaneously trying to book the seat. So obviously only one of them should get, isn't it? So that is the time when you have to deal with concurrency. Okay. So all the requirements related to concurrency will go under this category. So once you have written down all the requirements, your next goal is to write down the entities. So you would go through each and every requirements and write the corresponding entities. For example, let's say in this requirement, payment gateways requirement, the entities could be payment interface, Stripe payment gateway, PayPal payment gateway, payment status enum, etc. Okay. So you'd write the entities like this just for yourself. And once you have written down the entities, your next goal would be to connect those entities and try to understand the flow between those entities. Because if you don't even understand the flow, then obviously you won't be able to write the code. So in order to understand the flow, we would be drawing the class diagram. In an interview, you probably might not have access to the whiteboard, or maybe you won't have much time to draw the class diagram. So in that case, you can directly explain the flow. But in the LLD videos that I'm going to make, I will be explaining you the flow through the class diagram. Okay. And in the class diagram, I would be basically using these two kind of relationships. Either relationship is between class 1 and class 2 when class 1 is a child of class 2. Okay. And has a relationship is between class 1 and class 2 when class 2 is one of the attribute of class 1. Okay. So once we know the flow of our system, we would be easily converting that flow into working code. And these 5 steps basically would help you in your LLD round and in your machine coding round as well. Because the expectation in LLD round is to write down the requirements properly, to write down the entities, and to explain the flow to the interviewer. And in the machine coding round, the expectation is to write down the working code. And in all the LLD videos, we would be covering all these steps. That's why it would be helping you in your LLD and machine coding round. And by the way, I would be explaining this, or I would be embedding this particular explanation in each and every video for the first time visitors. But if you have already seen this particular part, 7 to 8 minute part, then you can skip that in all the other videos. Okay. So now let's begin with our current system. I think we all know about the parking lot. A parking lot is a place where you can park your vehicles, and that place can be small or huge. Huge as in it can have multiple floors, and on each floor it can have multiple parking spots like this, and your vehicle would be parked into one of those spots. For example, here you can see the bike is parked in this spot, the car is parked in this spot, and so on and so forth. So I think we know about the system very well. So we can start with the requirement gathering part. So I've classified the requirements into 3 categories: extensible, dynamic, and concurrency. In the extensible, I have noted down 4 requirements. The first one is, what are the types of vehicles should our system support? So currently, as you can see, our system has 3 types of vehicles: bike, car, and a truck. So is that all, or should our system support more in future? So the interviewer says that the system should be extensible to support different vehicle types. Maybe in future it can have bus as well. So it should be extensible. Okay. The second point that you can ask to the interviewer is, can a parking spot accommodate any vehicle type, or it has a specific vehicle type? For example, this particular parking spot that you are seeing over here is currently having car. So can I park bike also in this parking spot, or is it only reserved for cars? So this is your second question. And the interviewer says that no, each parking spot supports a specific vehicle. That is, this spot will support car, this spot will support truck, and so on and so forth. After these 2 questions, you can ask about how to charge your customer. So again, the interviewer says that I want that to be extensible. Assume that right now your system only support time-based charging. That is, during the peak hours or during afternoon, you will charge more, and during night you would charge less. But it should be extensible so that in future, if you want to charge your customer based on events, then you can do so. That is, let's say you want to charge more during New Year time. So you can do so. Okay. And we should also give the options to the users as well, right? Like they should have options like UPI, credit card, and cash. So these are different options to pay. So the fourth question could be, should the system support multiple payment methods or it should support only one payment method? So interviewer says that yes, it should have many payment method and it should be extensible. So I believe these are the 4 points that are more than enough in the extensible category. If you want, you can add more for the learning purpose, but I recommend you to keep it short during the interview, because interview is of, I think, 30-40 minutes and you have to cover all the requirements. You don't only have to write the requirements, but you have to solve those as well. That's why. So coming to the dynamic category, if you remember this category, in this category, we will take the input from the user. Your user can be admin. Okay. So the first question can be, how many floors and parking slots can the parking lot have? So are they fixed or you can add many parking floors and slots? So interviewer says that it should be dynamic. If I want to give if I want to make 5 floors, then I should be able to do that. If I want to make 100 parking slots in each floor, I should be able to do that. Okay, so this is the first question. The second question is, how many gates should our system support? So again, interviewer will say that system should have two types of gates, that is entry and exit gate, and we should be able to create many entry gates and many exit gates. Let's say I want to create 5 entry gates and 2 exit gates. So I should be able to do that. Okay. And interviewer might also explain about the functionality of the entry and exit gate. The first one is the functionality of the entry gate. That is, it will generate the ticket and give that to the user. And that ticket will have various details like what is the vehicle, what is the entry time, and what was the parking spot allocated to that vehicle, and all those stuff. And at the exit gate, the vehicle should be charged. And you have to provide this ticket at the exit gate. Okay, at the entry gate, you will get one ticket, and at the exit gate, you have to give that ticket. And according to that ticket, we will calculate the final cost. Okay, so these were the requirements in the dynamic category. Now coming to the concurrency part, the first question that you can ask is, are we building a system for just one physical parking lot, or do we want to scale it to multiple lots in future? So we'll assume that we are building for only one parking lot. Okay, we want to keep this simple. And in the interview also, interviewer will definitely agree to that. But let's say after the question, okay, after the end of the interview, interviewer can ask, what will you do if you want to support multiple lots? So don't worry, I will briefly explain that to you while explaining the class diagram. Okay. And the second question is, do we need to ensure that no two vehicles get the same parking spot? So what I mean by this is, so this is the spot which is allocated to the bike. Now assume that one bike comes from the entry gate 1, and at the same time another bike comes from the entry gate 2, and we know that only one spot is available. So which of them should get? Should both of them get the same spot, or only one of them should get, or none of them should get? So what should happen in that case? So we have to cover that as well. As you can see, the interviewer says that yes, I want you to cover that scenario. Okay. So I hope now you know all the requirements properly. If you haven't understood any of this, please comment down. I'll try to answer that. So now let's note down the different entities which are present in our system. So for that, what you have to do is you have to scan each and every requirement one by one. In the first requirement, we can see that one of the entity is vehicle, and there are different vehicle types. So we can have this vehicle type enum and different vehicles as well. So these are classes: bike, car, truck, bus, etc. So these are some of the entities that we have seen till now. Then in the second requirement, we can see that there is a parking spot. We are talking about parking spot. So this is one more entity. In the third requirement, we can see that we are dealing with pricing strategies. Okay. So here, I think this is the good opportunity to use strategy design pattern. Why are we using strategy design pattern? The reason is very simple, because let's assume that currently these are the two types of algorithms you are using in order to charge your customer. But in future, you want to introduce third algorithm. So strategy design pattern helps you to do that without modifying the old code. Okay. So that's the reason why we are using the strategy design pattern over here. And in the strategy design pattern, if you know, we have something called as strategy interface. So one entity could be pricing strategy interface, one could be time-based strategy, one could be event-based strategy. So these are the three different entities. Now again, for the same reason, we will use strategy design pattern for the fourth requirement as well. There, uh, there we would create the payment strategy, and the concrete strategies would be UPI strategy, credit card strategy, and cash strategy. Okay. So you should be very clear about why are we using design pattern over here. Because we don't want to change our old code and we want to extend our system. We want to make it extensible. That's the reason why we are using this design pattern. Now, if we scan this particular requirement, we see that floor is one more entity, and we have already covered parking spots. So no need to cover this. And yeah. And in the second point, we can see that there is something called as entry gate and exit gate. So these are some more entities over here. Okay. And here we can see that we are generating a ticket which will have many information. So this is one more entity. Right. And in the concurrency part, I think we don't have any entities. So I hope now you understood how to go with the requirement gathering part and how to note down the entities. If you did, then please like the video and keep watching. Now let's understand the class diagram of our parking lot system. In order to understand this huge diagram, we'll try to understand small chunks at a time, and finally we'll understand the entire flow. So let's start with the pricing strategy first. So over here, I have created the pricing strategy interface, which has this abstract function called as calculate fee. And this function will take three inputs. First is type of the vehicle, and the entry time and the exit time of the vehicle. Why am I taking this input? Because I want to charge the vehicle based on time and based on the type of the vehicle. The car will be charged differently and the bike will be charged differently. And these are the concrete strategies which will implement this function. Now coming to the payment strategy, this is the interface and it has one function called as pay. This function takes two inputs. First is the ticket, because ticket will have all the information of the user, and second is the amount that this user will pay. Okay, and the concrete implementations of pay function would be provided by card payment strategy and the cash payment strategy. And if you have seen my strategy design pattern video, there I have shown you that there is something called as context. There is one class called as context. In that class, we inject the strategy. So that's what I have done over here. This is the context, and we will inject the strategy into this context. And when we call this pay function, passing the ticket and amount, automatically the strategy's pay function would be called. So if we have injected the card payment strategy, then pay function of this class would be called. Okay. So this was about payment and above was about pricing. Now coming to the gate. So I've created one abstract gate class which will have all the common attributes of entry and exit gate placed over here. And this entry gate will have a function called as park vehicle. It will take the vehicle, it will take the entry time, and it will give the ticket. The actual logic of this park vehicle will be placed into the parking lot class. Here we would not compute, or we would not have the logic. This is just you can say controller type of stuff. That is, the request will first go to this entry gate, and this entry gate will delegate that request directly to the parking lot. Parking lot will park the vehicle, do all the logic, and it will give the ticket, and ticket will be returned to the user. Okay, don't worry, you will understand this with the help of code. In the exit gate, we have this unpark vehicle function. Again, the actual logic will be present in the parking lot. This is just like controller type of stuff. So we have covered the gates as well. Now talking about the vehicle, I have created one abstract vehicle class where all the common attributes of each and every vehicles would be placed. Okay, and these vehicles are the concrete classes which will inherit this vehicle class. Like bike will inherit vehicle, car will inherit vehicle, so on and so forth. Okay, and this is the enum. And currently, let's say our system has car, bike, and truck. In future, if I want to add bus, so I have to come here and write bus, and I can easily add one more class over here. Okay, so, and yes, I will be using one vehicle factory design. I will be using factory design pattern in order to create the desired vehicle. Why am I using the factory design pattern? Because of the obvious reason, I don't want if else condition in the client code. I want to delegate that if else condition into this centralized class called as factory. If you don't know about factory design pattern, please have a look at my video regarding factory design pattern. Now coming to the parking floor, coming to the parking lot, this parking lot will have parking floors. It will have multiple parking floors. Okay, I have used map. You can also use list, but I've used map because I want to query through the floor more efficiently. Parking lot will have parking floor. It will have multiple parking floor, and each parking floor will have multiple parking spot. Again, I have used map over here. So parking spot is over here. And we would have one function called as find available spot. where I would give vehicle type as input and I will get all the spots available for that vehicle type on this particular parking floor. Then we have parking spot, and each parking spot will have ID, type of vehicle which is allowed. So as discussed earlier, that only one type of vehicle should be allowed in a particular parking spot. So that's what we are doing over here. And we have to also deal with the concurrency part. So for that, I am using atomic Boolean variable. Why am I using this? Because see, there are multiple options. First is synchronize keyword. If you use synchronize keyword, there is certain disadvantage to that. I'll be explaining that to you in the code section. And instead of synchronize keyword, we can also use reentrant lock. Again, I will explain that to you in the code. And the most efficient among, and this is the third one, and the most efficient among these three is the atomic Boolean variable. And that's the reason why I have used this. Okay, I'll be explaining this atomic Boolean variable, the synchronize keyword and reentrant lock, like in briefly in the code section. And this ticket class will have all the metadata like ticket ID, entry time, floor ID, spot ID, vehicle, and the payment status. Okay, so initially the payment status would be pending. So I have not created the enums over here in this class diagram, but in the code I have created the enums as well. So coming back to the parking lot will have multiple floors as discussed. It will have active tickets. So here we would store all the tickets which we have generated. And we also have the pricing strategy, because we want to charge the customer based on certain algorithm. And that's the reason why this strategy is present in the parking lot. This is the business requirement. That's the reason why this strategy should be in the parking lot. Parking lot will decide what type of algorithm they have to choose for pricing. Okay. User will not decide. Parking lot will decide. Then we have some general functions like add floor, get instance. Okay. So by the way, I am going to make this parking lot as a singleton class, because as discussed, we only need one parking lot in our system. So singleton class will do that. And yes, I also told you that I will explain what will happen if we have to deal with multiple parking lots in place of only one. So what we will do in that case is we would have one parking lot manager. Okay. And instead of making this class as a singleton class, we would make parking lot manager as a singleton class. And this parking lot manager will have a map of parking lots. Okay. It will have a map of this parking lot. And this map would not be the ordinary map. This map would be concurrent map. Why? Because see, understand this with the help of one example. So parking lot manager will have multiple parking lots. Okay, so assume that it has 3 parking lot, and let's say this parking lot is in Mumbai, this parking lot is in Bangalore, this is in Gujarat. All of them are empty currently. Let's forget about this two stuff. Let's only work with this parking lot which is present in Mumbai. And let's assume that bike and car, both of them come simultaneously to this particular parking lot. Okay. And if we use a normal map, then what will happen is both of them will modify this object simultaneously. So they both will see that, okay, currently parking lot is empty. So bike will get this object which is empty, and car will get this object which is empty. Now bike will park itself in this empty parking lot, and car will park itself in this empty parking lot. Okay, bike will modify this parking lot which is present in the manager, then this particular car will modify this. So at the end of day, the parking lot which is stored in the parking lot manager will have only one vehicle, which is car. The detail about bike is lost. And the reason behind that is both of them modified the same parking lot at the same time. In order to avoid that, we would use concurrent map. Okay. And this is the out of scope. This is, I believe interviewer will not go in deep. Okay, forget about this stuff. Just assume that we would have one parking lot, and this parking lot is a singleton class. And we have the park vehicle function. This park vehicle function will park the vehicle. And this is the entry time at which this vehicle would be parked. And the unparked vehicle will be unparking this vehicle at the exit time. And this is the payment mode selected by the client. Okay. So I hope now you understood each and every block. Now, if I have to just summarize the entire flow, what will happen is this is the client. This is the client. It will go to the gate, specifically the entry gate. The entry gate has a function called as park vehicle function. So client will call the park vehicle function. This park vehicle function's actual logic lies in the parking lot. So parking lot's park vehicle function will be called. Okay. In the park vehicle function of the parking lot, what we would do is we would go to the parking floor, go to the parking spot and park the vehicle if a spot is available. Okay. And we would also generate the ticket for the user. And we would return the ticket back to the client. Done. So this was the flow for the park vehicle function. Regarding the unpark vehicle, again, client will interact with the exit gate. This exit gate has the unpark vehicle function. The logic of that function lies in the parking lot. And for the unparking the vehicle, we have to do several stuff. The first is we have to calculate the fees of the vehicle. So this parking lot will first interact with the pricing strategy. Okay, so it will first calculate the fees, and with the help of the ticket that user provided, it will not only ticket but also the payment mode the user provided, it will charge the user. We will call the payment strategy. So this parking lot will interact with this component. Once everything is done, it will free the space which is available over here in the parking spot, and we would return back to the client. So this is the flow. I hope you understood the flow completely. Now let's see the code. Okay, so now let's see the parking lot code. So this is the client code. Over here, I have created the instance of the parking lot. This is the singleton instance. And I have also created couple of gates, entry gate and the exit gate. And I am setting the pricing strategy to this lot. So we would be charging the user based on event. Okay. We would be charging the user based on event. In place of event, you can, let's say, do time-based charging. And I have created one floor, let's say floor 1. And in this floor, on this floor, I have added 4 different spots. One spot is for the bike, two spots are for the car, and one spot is for the truck. Finally, I have added this floor into the parking lot. Now, I have created one car with the help of factory design pattern. Okay. And this is the car which will come to the entry gate at this particular time. So we would call the park vehicle function of the entry gate. This is the time at which this car got entered. So we would get a ticket. Okay. Once the car is parked, we would get the ticket. And then I'm logging some stuff. And finally, I will exit the parking lot using the exit gate. And at the exit gate, I would pass the ticket ID, I would pass the exit time, and I would pass the payment option that I want to select. So let's say I want to select UPI. So I'll do that. And again, I am logging certain stuff. So let's run the code and see the output. So as you can see, first the vehicle is parked. Okay. And the parking lot will look something like this. It is showing that the car is parked because we had a car, right? So car is parked into this particular parking spot. Now, during the exit, we would be paying 170 rupees via the UPI. So this was the option that user selected, isn't it? And we would be exiting the parking lot. And this is 170. Why it is 170? It is based on the time. Okay, based on the time based algorithm. So in place of time, if I select, let's say car, sorry, not car, let's say event, and if I run the code again, this is 300. Again, it depends on the algorithm. I will explain the algorithm in briefly. So I hope you understood this output. Now, one more thing that I want to show you is regarding the multi-threading, the concurrency part. So let's copy this and let's comment this and paste that over here. As you can see over here, I'm trying to simulate one situation where two bikes are coming to the parking lot at the same entry time. Okay, I am trying to simulate this with the help of multi-threading. I've created two threads and I'm starting them simultaneously. And here you can clearly see that there is only one spot available for the bike. So ideally only one of them should get, isn't it? And that's what will happen. Only one of them should get. As you can see, only one vehicle, there is only one bike was parked. The other was shown this message, that is no spot available for the vehicle type bike. Okay. If I don't use that atomic boolean variable, then I will get vehicle parked message 2 times. So basically our system handles the concurrency part and it also handles the normal parking and unparking logic. Okay, now I will be going through each and every classes in the parking lot system. And after that, I will be explaining you why I did not go with synchronize keyword and instead used the atomic boolean variable for the concurrency part. So what I have done is I have segregated each classes into this categories. So all the enums would be placed into this enums folder. All the factories would be placed into this factory folder, and so on and so forth. Now let's look all of them one by one. So our system would have two types of gates, right? Entry and exit. So that's the reason why I've used this gate type enum. Regarding the payment mode, we would be having the cash, UPI, and card payment. But in future, if I have more payments, I can come here and add this, uh, modify this enum. Then regarding the payment status, these are the three types of payment status. Whenever we would be creating or yeah, whenever we would be creating the booking, at that time the payment status would be in pending state, and whenever the user will pay for the bill, that time the payment status will be either successful or failed. Regarding the pricing strategy types, so there are two types. The first is time based and second is event based, and the vehicle types are this. So these were the enums. Now let's have a look at factories. So as discussed, our system would be having a factory in order to create the cars, or I mean vehicles. And we are doing so that we can centralize the object creation process instead of having this process in each and every client class. Okay. So this was the vehicle factory. Similarly, we have the factory for the pricing strategy. So see, we would have a payment processor, right? Payment processor, and it will call the pay. And this pay function will be in using the strategies pay function, isn't it? It will be using the strategies pay function. The strategy itself is one object. It can be either cash payment strategy or UPI payment strategy or card payment strategy. So in order to create that object, we have to use factory design pattern. So that's the reason why I'm using factory design pattern first to create the strategy object, and I will be injecting that strategy object into this payment processor class. Okay. Similarly, we also have pricing strategy factory as well. We are doing the same stuff. Now, coming to all the models. So, yeah. So we have one vehicle class, and this is abstract class. So all the common attributes between bike, car, and truck would be stored into this class. For example, they all would be having a number plate. Okay. So this was the abstract vehicle class. And by the way, I'm using Logbog annotation in order to create the constructor and getters. So, and that's the reason why all of my classes are very short in length. Then we have the bike, which will extend the vehicle. Okay. So in future, if there is some attribute related to bike, you can come here and add that attribute in this bike class. Similarly, we have car and truck class as well. Then we have entry and exit gate. So there is one gate which is abstract class, and all the common attributes would be present in this gate class. And we have one abstract function called as get type. So both of these classes will implement that abstract function. For example, the entry gate will return get type dot entry when we call the get type. Okay. And as discussed, the entry gate will have a function called as park vehicle, and these are the attributes which we have to give as input. And the actual logic of parking the vehicle will be present into the parking lot. So that's what I'm doing over here. I'm saying that, hey, parking lot, please call your park vehicle function, generate the ticket, and return the ticket to the client. Okay. So this was the entry gate. Similarly, we have this exit gate. In the exit gate, we have unpark vehicle function, and we are doing the same stuff over here. Now, So we also have parking floor and parking spot. So a parking lot will have multiple floors. So each and every floor will have an unique ID and it will have map of spots. And this is the constructor for initializing the parking floor. And we can also add multiple spots into this map using this add function. But the key function over here is find available spot based on the vehicle type. So for this, I am iterating through each and every parking spot on that floor. By this, what I mean is this spot allows this type of vehicle. So first I will be checking whether this vehicle is allowed to park on that spot. After that, I will try to occupy that spot. Okay, I will check whether it is free or not. If it is free, then I will try to occupy that. And this function is atomic in nature. I will explain this to you in a second. And if we are successful in booking that slot, then we would return that slot. And let's say if we do not find any spot on the current floor, in that case we would return null. So this is the parking spot, and here we have that try occupy function. In the try occupy function, I am using the compare and swap technique in order to turn this variable from false to true. Okay, so whoever tries to park the vehicle at that spot will convert this variable from false to true. And this is not an ordinary Boolean variable, but it is atomic Boolean variable. It means that this operation would be atomic. That is, if let's say thread T1 and thread T2 both tries to call this function simultaneously, this function, then only one of them will be successful in converting this false to true, other will fail. Okay, so and that's the reason why, let's say two bikes come at the same time and only one spot is available for bike, then only one bike will be getting the spot, other will fail. And since other failed, this will return false. So false and true is false, so this if statement would be skipped. Okay, so I hope you understood this stuff. So under the hood, this try occupy, I mean this atomic Boolean variable uses compare and swap technique, which is a lock-free mechanism in order to convert the variable from false to true. Okay, so what happens basically is initially both the threads will see that the expected value is false. I mean, initially both of the threads will see the occupied is false. So they both will try to convert this from false to true. So for that, as discussed, only one thread will be allowed at a time because this operation is atomic. So let's say thread T1 or let's say thread T2 converts from false to true. Okay. Now it's time for thread T1 to convert it. But thread T1 will see that the expected value is false, but the new updated value is true. So it means that there was some other thread which converted this variable to true. And that's the reason why it will remain false. Basically, it will fail. Okay. So this was about atomic Boolean variable, and we are using that in order to achieve concurrency. And let me explain why I am not using synchronize keyword as well. So in the parking lot, we have a function called as park vehicle, and we want to park a vehicle in synchronized way, isn't it? That is, let's say two bikes comes at the same time and only one spot is available, then only one of them should get. This is what we want. And thinking this, many people might use synchronize keyword. Now this will do that job which we want. Okay, this will prevent this scenario. But there would be one issue. The issue would be let's say one car comes and one bike comes, and we have sufficient spots. Then also, first bike will go into this function. It will execute this entire function till here, and after that car will go into this function and it will execute the function entirely. So this basically slows down the process. Okay, even though bike and car both are different and we have sufficient amount of spot, then also we are locking this function. Okay, and that's the reason why the entire system will slow down for this park vehicle function. Now let me just explain you the different strategies. The first one is pricing strategies, and we have, so this is the pricing strategy, and here we have a function called as calculate fee. So in order to calculate the fee, we have vehicle type, entry time, and exit time. On the basis of this parameter, we would be charging our customer. So the first one, let's say, is the time-based pricing strategy. For that, what I've done is I've segregated the time. The time which fall between this range belongs to the peak hour. So this is 8 a.m. to 5 p.m. and all the other hours are non-peak hours. Okay, and this is one function in order to check whether any time lies between this range or not. Okay, now the main function is calculate fee. So first I'm getting how many minutes a vehicle was parked, and after that I am trying to round it off to nearest hour. That is, let's say I parked my vehicle for 43 minutes. Then also I will charge the customer for 1 whole hour. So that's the reason why we have to round off. And after that, I am trying to know how many hours were the peak hours and how many hours were the non-peak hours out of those total hours. Okay, so for that I'm using this chrono units, I mean this truncated to function. So what it will do is, let me just show you that. Yeah, so this is the time at which the vehicle is entered into the parking lot. So if I print that thing over here, so here you can see that the time is 7 a.m. even though the vehicle entered at 7:30 a.m. So basically what is happening is we are pointing to the first hour. We are rounding off and we are pointing to this entire hour, 7 to 8 a.m. hour. So in that, so I will be basically checking whether that 7 to 8 a.m. was a peak hour or not. If it was peak hour, then I'm incrementing this variable, else I am incrementing this variable. And finally, I'll be incrementing this cursor. So cursor is first pointing to 7 to 8 a.m. Then it will point to 8 to 9 a.m. and so on and so forth. So this we would repeat for total number of hours. So finally, once we know what is how many peak hours were there and how many non-peak hours were there, I am calculating the cost. Okay, so for each vehicle we have different costs. That is, for the peak hours, the cost for the vehicle would be $30, and it would be $20 for non-peak hours, and so on and so forth. So this was time-based pricing. Similarly, we have event-based pricing, and pricing for events are fixed. That is, let's say for New Year, car will be charged $50 and so on and so forth. So in this function, I'm repeating this step again in order to calculate the total number of hours for which the vehicle was parked. And after that, I am getting the rate per hour, okay, for the type of the vehicle. So here I'm passing the vehicle type as an input. So accordingly, I'll get the rate per hour, and I'll multiply the rate per hour into total number of hours. So this is how we calculate the time-based and event-based pricing. Now coming to the payment strategies, this is very simple. So here we have this payment strategy class, I mean interface, and it has this abstract function called as process payment, and it takes two inputs. First is ticket, which has all the user data, and second is the amount for which we would be charging the user. And we have this concrete strategies. First is cash payment strategy. So in real world, you would be having the actual logic to deduct the amount over here. So you would be interacting with your payment gateway and deducting the amount, and if it is successful, you would return true, else you would return false. So this we would repeat for each and every strategies. And as discussed, we have one payment processor context. In this, we would be injecting the strategy, and we would call the pay function of this payment processor. So if the strategy injected is UPI payment strategy, then the process payment function of UPI payment strategy would be called, and it would return true or false. If it is true, it means that payment was successful. Hence, we would turn this payment status from pending to success. Else, we would turn that to failed. Okay. Now, coming to the last and the main class. So this parking lot is a singleton instance. Hence, I have this static final variable and it is private. So I have created the object over here. So basically we are eagerly initializing the object. Okay. And we have this function called as get instance. So all the classes which wants the instance of parking lot will call this function, and we would return the instance. And the parking lot will have map of floors. So this is the ID, this is the floor, and it will also have the active tickets. Apart from that, it will have the pricing strategy on basis of which it will be charging the customers. So by default, I have set that to time based, but you can modify the strategy using the setter. So I have the setter annotation as well. And this is the add floor function in order to add the floor. Now remaining two functions are the main function. The first one is park vehicle and second one is unpark vehicle. So in order to park vehicle, I am going through each and every floor and I am calling this function, which is find available spot on that floor based on the vehicle type. And as discussed, here we are using that atomic function, that is this function. So only one vehicle will be getting the booked slot. Okay. Only one vehicle will be able to book a specific spot. And if the spot is not equals to null, it means that that vehicle was successful in booking a slot or spot. And in that case, we would be generating a ticket. Okay, we would be creating a ticket. And talking about the ticket class, this has all the attributes like ticket ID, entry time, exit time, sorry, not exit time, entry time, vehicle, floor ID, spot ID, and the payment status, which would be by default pending. And I have used builder annotation in order to make this as a builder class, basically a builder design pattern. I'm using builder design pattern over here because this has lots of attributes and it is good to have this chaining. That's the reason why I've used. Otherwise, you can also use the constructor, which would be very long. But yeah, that's your choice. And after that, I'm putting this ticket into the active tickets map. And finally, I'm printing some messages. And yes, by the way, instead of logging the messages like this, you can use custom exception handling as well. You can create your custom classes for exception. For example, no spot found exception, no spot available exception, and so on and so forth. But I have not created that. I leave that up to you. But it is good to create that or at least mention that in the interview. Now remaining is the unparked vehicle function. For that, I have passed ticket ID as the input and exit time and the payment mode, which I want to use for paying the parking lot, paying the bill. So first we would get the ticket from the ticket ID. After that, I am checking whether the ticket is null or not. Again, you can use custom exceptions as well over here. And finally, I'm trying to calculate the fees using the pricing strategy. And once I calculate the fees, I am using the factory in order to create the payment strategy, and I'm injecting that payment strategy into the payment processor. Now this processor will call the pay. So it will be either successful or failed. If it is failed, so again we would log payment unsuccessful message, or you can always use custom exception classes. And if it is successful, in that case we would free this spot. As you can see, we have a function called as vacate. In that case, I would make this occupied variable to false. And finally, we would remove the ticket from the active tickets. So I hope now you understood the park vehicle function and the unpark vehicle function. And this covers our parking lot from end to end. So if you understood this parking lot system, then please like a video and share this with your friend. Thanks for watching.